Here's the problem. You're given an integer array, and you need to find a continuous segment of it whose elements add up to the maximum possible value. The key word is continuous. You can't skip around. For example, in this array, the maximum subarray is 4, -1, 2, 1, and the sum is 6. Sure, if you picked all the positive numbers, the sum would be even bigger, but that's not allowed because they're not contiguous. The most straightforward idea is brute force. You try every possible subarray. For example, take the first 4 elements. You fix a starting point, try every possible ending point, compute the sum of that range, and keep track of the maximum. This does give the correct answer, but it's extremely inefficient. There are O(n) squared subarrays, and computing each sum directly costs another O(n), so the total time becomes O(n) cubed. Even if you use prefix sums to speed up the range sums, it's still O(n) squared, which is far too slow for large arrays. So what's the better way? This is where the famous Kadane's algorithm comes in. It's elegant and very efficient. As we scan the array from left to right, we maintain 2 values: current sum, the best possible subarray sum that ends at the current element, and max sum, the best subarray sum we've seen anywhere so far. For each new number, we ask, should we keep extending the current subarray, or should we start a brand new subarray from here? If adding the new number gives a larger sum, we keep going. But if the new number alone is larger, that means the previous subarray was dragging us down, so we restart from this element. Let's walk through the example. At the beginning, both current sum and max sum are set to -2. Then we move to 1. 1 is greater than -2 plus 1, so we restart from 1. Current sum becomes 1, and max sum becomes 1. Next is -3. 1 plus -3 is greater than -3 alone, so we keep accumulating. Current sum becomes -2, while max sum stays the same. We keep applying the same rule as we move forward. And by the time we reach the end, max sum holds the value 6, which is our final answer. The Python code is very simple. Current sum keeps the running subarray, max sum stores the best result so far, and both start as the first element. As we scan through the array, we decide whether to extend the current subarray or start fresh from the new number, and then update max sum. At the end, max sum is the answer. Kadane's algorithm makes just one pass through the array, giving O(n) time and O(1) space.